Hi everyone, in today's video we're going to be solving a problem on instantaneous acceleration and instantaneous velocity. Coming right up. The question is, if I have a particle and the position is given by the formula x of t equals to 2t cubed minus 9t squared plus 12, when is the velocity equal to 0? And then the next question is, what are the particle's position and acceleration at these times when the velocity is equal to 0? So let's start with the first question. All we have to do is first, well, this is only our position equation, so we need to find our velocity equation from this, so we can equal that to 0 and get our times. It's actually very simple. I'll just go ahead and do that. So my velocity equals to, remember, all you have to do is multiply your exponent to your your constant. So I have 2 times 3 t, and then you have my exponent is n minus 1. So in this case, 3 minus 1 minus 9 times my exponent is 2 t2 minus 1, and then, well, my 12 is just equal to 0 because the derivative of a constant is just 0, so I'm not going to add it there. So my velocity goes to 6t squared minus 18t. Now, we need to find my velocity, my time, when my velocity equals to 0, so I'm going to add this equals to 0 equals 2. And I'm going to factor out a 6 because I can multiply that by 6 and then add t. So I have t again minus and then 3 because 6 times 3 equals to 18. So once I factor this out, I get those two terms. So then it's very simple. I have my 0 equals to 6t and 0 equals to t minus 3. My times when the velocity equals to 0 are, well, t equals to 0 in this case, and my t equals to 3 in this case. So we finished with the first question here. Now let's do the second one. For the position, all we have to do is plug these numbers back in here, and then we get our position. So let's do that for now. Then once you calculate this, you're going to get minus 15 meters. So that was easy. For the acceleration, what you have to do is actually very simple as well. You just have to derive your velocity formula once again, because the change in velocity equals your acceleration, just like the change in position equals your velocity. So let's start from here and work from there. So what's the derivative of this equation is acceleration of t equals, and then again, so I bring my exponent down, I have 6 times 2 t, and then 2 minus 1, so let's write it all down, and then I have minus 18 times 1, and then my t, 1 minus 1, it's just gonna be the constant 1. So my acceleration equals to 12 t minus 18, and like I said, t to the 0 is just a constant 1, so we don't have a t there. My acceleration when my time equals to 0, which is the first one we got here for position, equals to, this is just 0 minus 18, so my acceleration is minus 18 meters per second squared. And my acceleration with t equals to 3 equals to 12 times 3 minus 18, which is just equal to 18 meters per second squared. So at t equals to 0, my x is 12 meters, my velocity is equal to 0, and my acceleration is equal to negative 18 meters per second squared. and then at t equals to 3, I have my position equal to minus 15 meters, my velocity again equal to 0, and my acceleration equals to 18 meters per second squared, and that's your answer. So to summarize what we just did, when we have a position formula, we just have to derive it once to get the velocity, and then you derive it again to get the acceleration. In the next video, we're going to be integrating our velocity formula to get back our position. If you have any questions regarding what we just saw today, please let me know.